Now here, moment at point A will be equal to, we are again continuing this thing, that first of all 40 multiplied by 0, okay, 40 multiplied by 0 plus again this 40 which is in anti-clockwise direction, that's why its sign will be positive, to this distance 1.5, okay, into 1.4. So finally you will get 60 Newton meter. Okay, now after that we'll again calculate the moment at point B. Moment at point B, which is equal to, now for this point B, again what will happen, that your first force, that is this 40 Newton, is creating the moment like this. It is creating the moment like this. Okay. So again this moment is in anti-clockwise manner. As it is anti-clockwise, 40 multiplied by the 1.5, it will have a positive sign. Remember, this will have a positive sign. 40 multiplied by 1.5. Okay. Again, the next force, that is this 40 force, which is again passing through the point B, which is again passing through the point B. And therefore, its distance from the point B, because we are calculating the moment at this point B. Remember this thing, we are calculating the moment at this point B. So therefore 40 multiplied by 0 distance at this point B. 40 multiplied by 0 will be 0 again. Okay, 40 multiplied by 0 will be 0 again, plus 0, and therefore we'll get answer again 60 Newton meter. 60 Newton meter. Okay. So at point B also we got the same value. This means that the moment at the point A is also same, moment at the point B also same, and couple moment at the section AB is also same. So this proves our fifth characteristic, that the couple moment at any point remains same. Okay, but let's move further. We will also cross check this moment at the point C also. We'll cross check it at the point C also, that what value it will get at the point C. And this is the important part of this lecture. Okay, so I request everyone to keep attention. So for calculating the moment at point C, first of all, consider the force 40 Newton multiplied by the distance at the point C. Now this distance will be how much? Up to point C, the distance will be 2 plus 1.5, that is equal to 3.5 meter. 3.5 meter will be the distance here. Okay, so therefore this first force 40 Newton multiplied by 3.5 meter at this point, and this will create which type of moment? Again, this will create the anti-clockwise moment. Remember, again this will create the anti-clockwise moment at the point C. Okay, so therefore this anti-clockwise moment will be positive in nature as per our sign convention. So therefore plus 40 multiplied by 3.5 meter. Okay, next one is the again next force, which is the force which is in upward direction, which is 40 Newton. Okay, So therefore, this force now will create the moment in clockwise direction about point C. This will create the a clockwise moment. Remember this thing. This will create the clockwise moment at point C. So therefore, this is in clockwise nature. Remember this thing. This is the most important part, that this 40 Newton force is creating the clockwise moment at the point C. It is rotating the shaft. It is trying to rotate the shaft in clockwise manner. And therefore, the sign convention for the clockwise moment is negative. And therefore, we have to keep here negative sign. Negative 40, that is minus 40 multiplied by 2, which is again the distance. Remember this thing. The force multiplied by its perpendicular distance, which is 2 meter from the point C, and we are calculating the moment at the point C. Remember this thing. Okay. So therefore, 40 multiplied by 2 meter, that will be how much? 40 multiplied by 3.5 and 40 multiplied by 2. So therefore, we can take 40 common here. Okay. 40 common we can take, and 3.5 multiplied by 3.5 minus 2. Okay. So therefore, 3.5 minus 2 will be again 1.5. So 40 multiplied by 1.5, and at the end we'll get 60 Newton meter, the answer. At the end we will get the same answer. Okay, we have taken the 60 common here. This is simple arithmetic calculation. After taking the 40 common, we will have 3.5 minus 2, which is again equal to 1.5. So 40 multiplied by 1.5, 60 Newton meter. Okay. Now after that, again we'll check the moment at the point, last point, that is at the point D. Okay. So how to check the moment at the point D? Again, we have to consider the same forces. Okay, same procedure we have to follow, that moment at the point D. Okay, so first force we have to consider is again this 40 Newton force, which is going downward. So again, this will create a, what we can say, again this will create a anti-clockwise moment about the point D. About the point D, it will create the anti-clockwise moment. Okay, and anti-clockwise moment is positive as per our sign convention. So plus 40 multiplied by, now the distance will be more here about the point D. So the distance will be now how much? Distance will be 3.5 plus 2.5. So this will be 6 meter. Okay. Distance will be 6 meter. Now after this, 40 multiplied by 6 will be the moment by the first force. Okay. Now second force is creating the your clockwise moment. This 40 Newton force, which is acting in upward direction, will create the clockwise moment. So therefore, its direction will be clockwise about point D. Okay, about point D. So therefore, its sign convention will be negative multiplied by 40 multiplied by its distance about this point. So what will be the distance? This distance will be 2 plus 2.5, and that will be 4.5 meter. 4.5 meter will be the distance. So therefore 40 multiplied by 4.5. Okay. So again, we will keep the 40 common here. Have you understood that why we have taken the negative sign here? Because of its clockwise nature. Because of its clockwise nature. Okay. This is creating the clockwise movement. You can draw it here so that we can draw it here so that you can understand. This force will create the clockwise movement about point D. Okay, we can draw it, we can show here. This 40 Newton force will create it here clockwise action. This which is acting in upward direction about the point D. Okay, so therefore 40 is taken common here. So 6 minus 4.5. 6 minus 4.5. Okay. So again, we are getting here 40 multiplied by 1.5 at the end and 60 Newton meter. So now at the end, we have proved here that our assumption, or what we can say, our characteristic of the couple moment was exactly right. That moment by the couple at any point remains constant. So at the point A, B, C, D, we have got the same values, that is 60 Newton meters. So at the final, it has been proved that the value of the moment never changes. Value of the moment never changes and it remains constant. So therefore 60 Newton meter value always remains constant. So in this lecture, you came to know the difference between moment and couple, as well as the difference between bending moment and the normal moment. Okay, so that difference you came to know here, as well as we have solved one numerical based on the, what you can say, your couple. Okay, so our time limit is ended here. Okay,